Picking up where we left off, we had developed a couple of trig identities. Cosine of pi halves minus theta is sine theta. Sine of pi halves minus theta is cosine theta. And now I'm going to use that to get the angle addition formula for the sine. Well, so the sine of alpha plus beta is, I'm going to write it in terms of cosine. Well, what is it? Well, the sine of theta is the cosine of pi halves minus theta. So I can write this as the cosine of pi halves minus, and then my theta is alpha plus beta. And now I'm going to think of this a little differently, group the alpha with the first. So it's the cosine of pi halves minus alpha, subtract beta. But now I can use the angle subtraction formula for the cosine. The cosine of this angle subtract this angle is what? Cosine of the first, pi halves minus alpha, times cosine of the second, plus sine of the first, pi halves minus alpha, sine of the second, right? And that's by the angle subtraction formula for the cosine, which was letter C. But what is cosine of pi halves minus alpha? Well, that's just sine of alpha. So this is sine alpha, cosine beta. What's this? Sine of pi halves minus alpha. That's just cosine alpha times sine beta. And there it is. There's the angle addition formula for the sine. Sine alpha, cosine beta, add cosine alpha, sine beta. Again, I'm using E and F. Now, finally, if I want the angle subtraction for the sine, I just have to write the sine of alpha minus beta as the sine of alpha plus minus beta. That's true, right? But then, since it's alpha plus this, I can use the angle addition formula up here, G, to give me what? It's sine of the first, cosine of the second, cosine of minus beta, plus cosine of the first, alpha, sine of the second, minus beta. Okay? But remember, cosine of minus beta is just cosine beta. Sine of minus beta, however, is minus sine beta by A and B at the very beginning of this. And I get sine of alpha minus beta is sine alpha cosine beta, subtract cosine alpha sine beta. And that is the angle subtraction formula for the sine. So angle addition and angle subtraction formulas for the sine and cosine are very useful, and I find people don't know them. How useful? Well, suppose I wanted the double angle formula for the sine. In other words, what's the sine of 2 alpha? Well, one way I could do it is the sine of 2 alpha is just the sine of what? Alpha plus alpha. And now I could use the angle addition formula for the sine, which says what? Sine alpha, cosine alpha, add cosine alpha, sine alpha. But do you notice this is the same as that? So I get the double angle formula for the sine to be sine of 2 alpha is 2 sine alpha cosine alpha. Isn't that nice? Now, what if I wanted the cosine double angle formula? Well, I could do the same kind of trick. Cosine of 2 alpha is the cosine of alpha plus alpha. Now I can use the angle addition formula for the cosine. That was letter D up here. And what did D say? It's just cosine of the first, cosine alpha, subtract sine alpha, but that could be written as what? Cosine squared alpha minus sine squared alpha, and that is double angle formula for the cosine. Now, there are a couple more double angle formulas for the cosine, and they all come from our famous Pythagorean identity, sine squared plus cosine squared is 1. So let's start with cosine 2 alpha again. Write it as cosine squared alpha minus sine squared alpha, except now let's replace sine squared alpha with, look up here, sine squared alpha can be written as 1 minus cosine squared alpha, taking this over. So if I put 1 minus cosine squared alpha here, and I clean things up, I get a minus 1, and a minus cosine squared, so it's plus. I get another double angle formula for the cosine. Cosine of 2 alpha is 2 cosine squared alpha subtract 1. Now I could take the same trick that I used up here, except instead of replacing cosine, I could replace, or instead of replacing the sine up here, I could replace the cosine. So cosine of 2 alpha is cosine squared alpha minus sine squared alpha, but cosine squared alpha is, by up here, 1 minus sine squared, so I put 1 minus sine squared here, minus another sine squared. I get 1 minus 2 sine squared alpha, and that is my third double angle formula for the cosine. This double angle formula gives it in terms of the sine of the angle, and this gives it in terms of the cosine. And the first one gives it in terms of both the sine and the cosine. Now, every one of these trig identities, for those of you who are going on to calculus, are going to be used extensively. So I would suggest you learn them. And in fact, there is a sheet under the handouts that give you these identities. Okay, so those are all the identities that Chapter 4 covers. Next time, we're going to do some examples similar to the homework.